Supervolcanoes are one of Earth's most spectacular geologic wonders, and now scientists believe they can also be one of our best sources of clean energy. Supervolcanoes have the power to create massive climate change when they erupt, but geothermal energy from these behemoths could also provide a carbon-free energy source for generations to come. Here's how we plan to tap into the power of supervolcanoes. First, let's get some definitions out of the way. A supervolcano isn't actually a type of volcano, but rather a term that refers to any volcano that has an explosive eruption with a volcanic explosivity index or VEI rating of 8. The largest volcanoes in the world are considered supervolcanoes. They typically form when two or more smaller volcanoes join forces and are capable of catastrophic eruptions that eject over 1,000 cubic kilometers of material. That's about 240 billion gallons. That volume is enough to bury all of the United States under 60 meters of ash and pumice. In fact, 4 of the 7 currently active supervolcanoes are located in the United States, including Yellowstone National Park, which is home to North America's supervolcano. Yellowstone lies mostly in the northwest corner of Wyoming, but extends into parts of neighboring Montana and Idaho. Covering an area the size of Belgium, it contains the world's largest high-silica magma chamber. It consists of 3 separate calderas, which are large, roughly circular depressions in the ground caused by the collapse of a volcano's summit. Over millions of years, Yellowstone has grown from a small hotspot created by rising magma to a massive supervolcano. Its 3 calderas stretch for about 43 miles across and plunge more than 1,000 feet below the surrounding landscape. Although supervolcanoes produce the largest volcanic eruptions on Earth, it's important to note that they don't necessarily erupt the most frequently. Eruptions of supervolcanoes happen at unpredictable intervals, ranging from thousands to hundreds of thousands of years. For example, the Toba supervolcano in Indonesia had its most recent major eruption 74,000 years ago. However, Yellowstone has been very active recently by comparison. The most recent eruption was 640 years ago, and there are signs of increased activity now. Since 1985, the park has experienced nearly 2,000 earthquakes. While most were too weak to be felt, some were strong enough to trigger steam explosions. In 2021, a magnitude 5.8 earthquake struck the region, which was the strongest quake to hit the area since the U.S. Geological Survey began keeping records. These events are raising both concern and interest in Yellowstone's immense power. Yellowstone's history is marked by both violent eruptions and quieter periods. The first caldera-forming eruption occurred about 2 million years ago. This was followed by a period of relative calm until the second eruption, about 1.3 million years ago. Then came the third and final episode of major volcanism, starting around 640,000 years ago, which created the Yellowstone caldera. During the Holocene epoch, which began 11,700 years ago, Yellowstone entered a quiescent phase. Now in this phase, although there was still seismic activity, there weren't any significant eruptions. This period is remarkable because it marks the longest break between eruptions of the 3 calderas. The reason for this change is debated. Some suggest that a mantle plume may have migrated, while others propose that changes in tectonic plate movement could be responsible. Regardless, this phase has lasted for a very long time, and some even speculate that it might continue for thousands more years. While Yellowstone is known for its geysers, hot springs, mudpots, and steam vents, what really makes them possible is the heat produced by magma deep within the Earth. Magma chambers are vast underground reservoirs of molten rock. They form when rocks in the Earth's mantle melt partially due to increased temperatures and reduced pressure. As magma accumulates, it creates magma chambers which can extend deep into the crust. These chambers are dynamic structures that evolve over time through processes such as the injection of new magma, extraction of crystals, and gas exsolution. They play a crucial role in volcanic activity and the production of igneous rocks. By understanding the formation and behavior of magma chambers, scientists can better comprehend the dynamics of volcanic systems and make more accurate predictions about volcanic eruptions. The temperature at the core of the Earth reaches approximately 5,000 degrees Celsius. That's about 9,000 degrees Fahrenheit. However, the surface of the Earth's core is around 5,000 degrees Celsius. Because heat from the core gradually dissipates as it approaches the surface, the average temperature at a depth of 5 kilometers is about 1,000 degrees Celsius, or about 1,800 degrees Fahrenheit. The temperature at a depth of 10 kilometers is around 500 degrees Celsius, or about 900 degrees Fahrenheit. At a depth of 25 kilometers, the temperature is approximately 180 degrees Celsius, or about 350 degrees Fahrenheit. Geothermal energy, also known as heat energy derived from the Earth, harnesses the thermal energy stored within the Earth's core and crust. The Earth continuously generates this energy through radioactive decay of elements such as uranium, thorium, and potassium. Geothermal energy is extracted by drilling deep into the Earth and utilizing either the high-temperature heat from the core or the lower-temperature heat closer to the surface. Harnessing the energy from magma chambers has long been an intriguing idea. Yet the process of extracting this energy remains a challenge due to several key obstacles. Firstly, accessing the extreme heat and pressure found in magma chambers requires drilling through substantial depths, typically several kilometers beneath the Earth's surface. Secondly, the corrosive nature of magma, which consists of molten rock and other materials, necessitates the use of specialized drilling equipment capable of withstanding these harsh conditions. Thirdly, the transportation of this energy to the surface without leakage or environmental contamination is another significant hurdle. And finally, ensuring the safety of operations in areas prone to volcanic activity requires careful planning and risk assessment. Despite these challenges, advancements in drilling technologies, materials science, and risk management strategies have made it increasingly feasible to explore the potential of harnessing energy from magma chambers. Now, why would we want to do this? Well, geothermal energy has numerous advantages as a renewable energy source. Unlike fossil fuels, it doesn't produce greenhouse gases during operation. It's a baseload energy source, meaning it can provide a constant supply of electricity, unlike intermittent sources such as solar and wind. Additionally, geothermal plants have a small land footprint compared to other energy generation facilities. Moreover, they operate with minimal noise and visual pollution. Geothermal energy is particularly suited for locations with high volcanic activity, where heat is readily available close to the surface. Countries like Iceland, the Philippines, and El Salvador have successfully harnessed geothermal energy. In Iceland, geothermal sources account for a significant portion of the country's renewable energy production and are used for heating purposes. The Philippines has developed geothermal plants in areas like Tonganan and Bacon Manito, which utilize the heat from Mount Apo and Mount Bulusan respectively. Meanwhile, El Salvador's first geothermal plant at Berlin is the country's main producer of electricity. In summary, harnessing the incredible power of magma chambers offers a promising solution to meet the world's growing energy demands while reducing reliance on fossil fuels. By overcoming the challenges associated with accessing and extracting geothermal energy, we can unlock a sustainable and environmentally friendly energy source. If you like this video, make sure to leave us a like and subscribe so you never miss any of our future videos. We have a ton of great content coming up that you're not going to want to miss. Thanks for